Welcome to our channel, The Cosmic Web. Today I'll be discussing the concept of standard candles in astronomy. Standard candles are objects such as stars with particular properties. What I mean is that from their brightness it is possible to infer their distance. If you think about it for a moment, this shouldn't surprise you. Common sense suggests that the further the location of an object, the dimmer it will appear. If you see a car at a distance and its lights become progressively brighter, then you know that that object is approaching you. Pretty ordinary, right? Unfortunately, astronomers do not have this luxury because the intrinsic brightness of one object can be more than 1 trillion times brighter than another object. Also remember that when we observe the sky, we're taking a snapshot of the universe as we see it now. So it's virtually static. Cosmic interactions take much longer than our lifetimes, or of humankind's existence, for most phenomena. You see, common sense is not of great help when we deal with space, and determining distances it's a little trickier. Here is where standard candles come in handy. Let's be a bit more scientific about light from distant objects. So here we have a source of light, S, and it's emitting the rays which are represented in red. And these rays cross different spheres. We have a closer sphere and a more distant sphere. Now, if you take an equally sized area A of the distant sphere and of a closer sphere, you will see that in the closer spheres there will be more rays passing through than that equally sized area A of a more distant sphere. This is known as inverse square law, and it takes its name from the fact that the surface of a sphere is 4 pi r squared. If you want to learn more about this interesting analysis, you should probably Google the term flux. As I said earlier, when astronomers make observations, they take snapshots of what the universe looks like now. Think about taking a number of overlapping pictures of that car as it approaches. This image represents what I'm talking about. As you can see, candles replace our car. The concept of standard candles was first applied in astronomy to a class of stars called Cepheid variables back in 1912. In those days, electricity and cars were not a commodity in every household, so candles were the most obvious choice for the analogy of our light source. I'll briefly discuss now Cepheids and show what similarities they have with other standard candles of even bigger scales. Cepheids are not easy to observe. In the galaxy M100, which we can partially see in the lower big picture, the Cepheid is contained in the red circle, and its change in luminosity is seen in those 3 pictures on top. As you can see, even finding the Cepheids is a process far from trivial. Now, let's see how Cepheids are standard candles. Most stars have a stable luminosity over a short amount of time, but Cepheids do not. They pulsate over a period of other days or months. Now, how long they take to pulsate is directly linked to their brightness at their peak, so to the total energy that they radiate at their peak over a unit of time. I found this excellent video from YouTuber Star Garu, which shows visually that the dimmer Cepheids have a shorter cycle and the brighter Cepheids have a longer cycle. This is what makes Cepheids excellent standard candles. I explained all of this to you because we're working our way to extremely interesting topics. Another type of standard candle are Type 1a supernova. A Type 1a supernova played a crucial role in the discovery of the accelerated expansion of the universe. Yes, you have heard me well. The very fabric of space and time is accelerating right now at ever faster rates. This phenomenon has been given the name of dark energy for reasons explained in other videos on this channel. So, I hope you enjoyed watching us today, and let's keep on learning!